All right, so we are going to evaluate some logarithmic expressions by basically doing what we ended with yesterday when we did the inverse. So I like to use x's and y's, Alex used a's, b's, and c's, but we said if we have the log base b of x equals y, we could rearrange it into exponential form by doing what?
Switching the x and the y.
So we would say b to the y equals x, right. And Alex, I think they use an A and a C, don't remember which order, but it's the same thing. But since I like to think of the inverse as switching the x and the y, I'm going to use x and y. So, log base 2 of 16 equals what? I'm going to just put a y there because that way it'll match up with my equation up there. So if I rewrite that in exponential form, I would say 2 to the y power equals 16. Now you just basically have to use your brain and figure out 2 to what power is 16. Well, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so 2 to the 4th power is 16, right? That means that I should have a 4 in there for my answer. I think they're going to have something like log base 2 of 16 equals, and you type in 4. So number 2, if I am going to rewrite that in exponential form, again, I'm just going to put a y just so it matches what I have up there. You can put whatever variable you wanted to.
6y equals 1.
6 to the y power equals 1 over 36. 6 to what power is 1 over 36?
Not 2, is it?
6 to the second power is 36. How do we make it do the reciprocal? Ah, it has to be negative, right? If you do 6 to the negative 2, you get 1 over 36. So, log base 6 of 1/36 is going to be negative 2. And so on number 3, again, I'm just going to stick a y in there for fun. If I rewrite that in exponential form, I would say 5 to the y equals 1. 5 to what power equals 1?
0.
0, because anything to the 0 power is equal to 1, exactly. So log base 5 of 1 equals 0. All right. So the first ones are always going to have you find the end number that's missing, but now on the next ones they're going to have you find just whatever's missing in there. Could be any of the 3 spots. So I want to solve this for x. I'm going to do the exact same thing I did up here to start. So if I rewrite this in exponential form, I would have 4 to the second power equals x. Well, that's easy enough to solve for x because I can do 4 squared, right? X is going to be 16. So that means the log base 4 of 16 is equal to 2 because 4 to the second power is 16.
So would you have to write that as your whole answer, the log?
They're just going to have you do x equals 16. So, number 5, if I rewrite that in exponential form, I would have x to the negative 3 equals 1 over 1,000. So now you have to figure out, well, what number to the negative 3rd power would give you 1 over 1,000? 10, right? 10 times 10 is 100. 100 times 10 is 1,000. So 10 to the 3rd is 1,000. Since I have to the negative 3rd, It would be 1 over 1,000. So try number 6 there. Did I unplug the wrong one?
Mm-hmm.
Probably. I had to use one of these plugins for my camcorder
Yeah,
to work.
'cause it doesn't even have the orange light on it.
I had to guess which plug-in to unplug.
You want me to just move?
Oh, we'll just try a different one. Now we probably unplugged your monitor. There, now do you have a light?
I'm good.
Is your monitor still on?
I'm
Is
good.
the hard drive still on? You didn't wonder on the video what was going on. So, if I rearrange this one, what am I going to have?
Why Jordan know this stuff?
Well, then you guys got to do it. She already proved she knows what she's
I
doing.
just learned this today. I didn't even learn
It
this
would be
yesterday.
x to the third,
It would be?
I ain't heard from
and
you.
it might be x to the third equals 3.
Which is your base? The little 3.
The little 3, okay.
So it's 3 to the third equals
Third
x. And 3 to the third is
27.
27.
Damn.
So it's always that little base. This becomes the exponent. That becomes the answer. All right. Translating my graph. Well, this should be the same thing we did when we translated all those other graphs that we translated, right? If the value is in with the x, it switches it left or right. If the number's on the end, it goes up or down. We have to remember with the x that we set that part equal to 0. So if we have x minus 1 equals 0, x equals a 1, and it moves 1 to the right, right? The end number just goes in the same direction as it looks. I'm going to go down 4. So I'm going to grab that dot, move it 1 to the right, down 1, 2, 3, 4, drop it, and then my new graph is going to show up over there. So number 8, if I am going to translate that one, how is it going to move?
To the left 2
To the left 2
and up 3.
and up 3. So I'm just going to grab my dot, move to the left 2, 1, 2, and up 1, 2, 3. 1, 2, 3. There's my new spot, and my graph will just move over there. So on number 9, you probably already finished this one already. How did that one move?
To the right 3 and up 2.
Right 3 and up 2. So 1, 2, 3 to the right, 1, 2 up. And then my graph will just move over there when I drag that point over. So it just works just like it did when we have absolute values and parabolas and all of those other things. The opposite of this, because I have to set it equal to 0 and solve, the same as that.
No.
Basic properties of logarithms. Now, logarithms are inverses of exponential functions. So the rules end up being the opposite of what they are for an exponential function. When we have x to the m times x to the n, we have x to the, and what do I do with my exponents? When my bases are the same, I add my exponents, m plus n. With a logarithm, if we have the log of m plus the log of n, we are then going to multiply. So we're going to say that it's the log of m times n.
Oh no. This is gonna be confusing.
So the bases would have to be the same. They're not going to give you any that don't have the same bases that you couldn't combine. if I have the log base 4 of 3 plus the log base 4 of 7, I'm going to get the log base 4 of 21. 3 times 7. So thinking about my exponential function again, if I have the x to the m divided by x to the n, what is my rule? I'm going to subtract x to the m minus n. So with logarithms, if I switch that around, if I have the log of m minus the log of n, I'm going to change it to a division problem. It's going to be the log of m divided by n.
So the answer is 9?
So the answer is going to be 9. Because I have the log base 5 of 8 minus the log base 5 of what would give me the log base 5 of 8 divided by 9. Well, this would have to be a 9 in there, right?
Is 21 not in the box?
I don't know.
Oh. No, I don't know that was.
I just probably wrote it there.
You definitely did.
My last rule. If I have x to the m raised to the nth power, what do I do with my exponents?
Multiply.
I multiply them. So, this is going to say, if I have something times my log, that this now is going to become the exponent over here. So it's going to be the log of m to the n power, if I can smash that in there. So when I'm multiplying times a logarithm, it then becomes the exponent on my logarithm. So, here, if I have 2 log of base 8 of 5, the 2 then becomes the exponent over here. So I would get log base 8 of 5 squared. And we know that 5 squared is 25. There, I'll try to write in the box. So 25 is going to be my answer. So when I'm adding logarithms, I'm going to end up multiplying them together. When I'm subtracting logarithms, I end up dividing. And when I multiply something times a logarithm, it then becomes its exponent. So those are the 3 rules for, or the basic rules anyway, for logarithms. Got those written down?
Yeah.
I have them written down.
Because when I move it, it's going to erase everything. So, number 11, it says the log base 3 of 7 minus the log base 3 of 5 equals the log base 3 of what?
7 over. Yeah.
7 over 5. And write small to get it in the box. So, when I subtracted my logarithms, I divide. Log base 7 of what? Plus the log base 7 of 4 would give me the log base 7 of 12.
8.
3.
I like the 3.
All right.
Why do I like the
It's
3?
half of the 8.
Because they have to multiply when you add.
Because when I'm adding logarithms, I multiply those values together. 3
Oh.
times 4 is 12.
Oh yeah. We already have the. Never mind that. I don't know.
Okay, so now we're going to do the tricky one. Log base 6 of 81 equals what times the log base 6 of 3? So this value here
Oh.
becomes the exponent here. The log base 6 of 3 to what power would give me 81?
9.
I don't think so.
That was my first answer too, or thought too, but no. What times what times what times what is 81? What times what times what?
I don't know, I just figured.
3 times 3 times 3 times 3.
I just figured 3 times 2
Right?
is 7 was 81.
Oh.
So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So it would be 3 to the 4th.
Okay.
That would give you 81.
Alright.
I was
So
doing
4
backwards.
times the log base 6 of 3 equals the log base 6 of 81.
I wasn't even doing it.
I was going backwards.
Okay, now you got to try number 12 then.
18, right? Hoka.
Okay, I'll go with that one.
6, right?
Mhm.
And I'm not even looking at the letters at all. I'm just looking at the numbers solely. That's it. Oh, 7.
I don't think so.
Right.
So, first one, we have the log base 7 of 2 plus the log base 7 of 9. Our rule when we're adding logarithms is to multiply, and so we got 18. Then we had the log base 5 of what? Minus the log base 5 of 7 equals the log base 5 of 6/7. So that box had to be a 6, because when we subtract logarithms, we change it to a division problem. Now here's the tricky one. This number in front of my logarithm becomes the exponent here. So I'm saying the log base 8 of what to the second power would equal the log base 8 of 25?
Fudge.
5.
Oh. Oh.
So when something's multiplied by my logarithm, I move it up to be the exponent, and then I try to make them equal each other. So now we are going to expand our logarithmic expression using those properties that we just talked about. So, if I have the log of z to the 5th x, I can expand it into the log of z to the 5th, and what sign should I put here? No, plus. Why am I going to use a plus? Because I'm timesing.
Ooh,
Plus the log of x, right? So when I'm multiplying, I'm going to expand it and change it into an addition problem. One other little thing I can do there. What can I do with that 5 on my z to the 5th?
what mother? Put them on the.
I can put it in front and make it multiplied times that. So 5 times the log of z plus the log of x is the expanded form of log of z to the 5th x. So my exponent is going to be multiplied times my logarithm. So number 14 looks pretty close to number 13. If I expand that, then what would I have?
Log of x plus z, or plus log of z 7.
And I can expand that just a little bit more than that.
Plus 7 log z.
There we go. Log of x plus 7 log of z then would be my final answer expanded all the way out. So go ahead and try number 15.
Check it out.
Okay, that's a z, right? Look at it for a minute. Okay, so when we expanded that, what did we get?
Log of y minus
Log of y minus
4 log
4 log
z.
of z, right?
4 log.
Since I have a division,
Logging
it's going to be a
minus.
subtraction when I expand it out, right? Then 16, 17, and 18 just going in the opposite direction. So here I have 1/3 log base 5 of w So I'm going to have log base 5 of w to the 1/3 power. I'm adding 5 log base 5 of x. So I'm going to multiply that by x to the 5th power. I'm subtracting log base 5 of z, so I'm just going to have divided by the z. Now sometimes I think on the Alex program they throw those extra parentheses around like that. I don't think they're necessary, but they like to put them in there. So number 17 looks a little bit trickier because now they threw some parentheses on there, but this becomes this exponent. So I would have z minus 6, whoops, I better put log base a. Log base a, z minus 6 to the 7th power. This is subtracting, so that's going to be over z plus 7 to the 4th power. And then again, on Alex, they probably put parentheses around that whole big thing when you try to type it in. So if you try to do number 18, what's going to happen with number 18? First of all, what should I probably do with this 2 because it's in front of that parentheses? What would I normally do with the 2 that's in front of the parentheses? Multiply it out, distribute it out. So I would have 2 log base b of v minus 10 log base b of w, and then plus the 3 log base b of z. Now I can go ahead and put it together. So I would end up with log base b of so I'm going to have v to the 2nd power, right? What's going to happen with this one? Divide it by to the not negative 10. That's why we divided, because it was negative. So just w to the 10th. And then what's going to happen to this? So it's going to end up being on the top. So anything that's positive will end up on the top. Anything with a negative is going to end up on the bottom of the fraction. Okay? And again, they probably have these extra parentheses. I don't know that they're really necessary, but I think they automatically throw them in when you try to type your answer. So we'll look something sort of like that. Change of base for logarithms, problem type 1. Now, see, we could have made those previous problems we did really simple, but they wanted you to practice switching it into exponential form. When I have the log base 8 of 6, I would have to say 8 to what power equals 6? And you probably couldn't figure that out very easily, right? No. So we have a formula in order to figure that out. We are going to take the log of the outside number, which is the 6, and we're going to divide it by the log of the base number, which is the 8. And then we're going to use our calculators. Calculators use base 10 logarithms. If there's not a base written there, it's assumed to be base 10 because our number system is base 10. So we're going to change them into base 10 logarithms, and we just end up dividing. So we're going to grab our calculator and put in the log of 6 divided by the log of 8. It says round your answer to 3 decimal places, which really means 3 places after the decimal. And so we're going to give our answer as 0.862, right? Is that what you got?
Yes.
Now, just for fun, before I do number 20, I'm going to slide back up to number 1. You have the answer there for number 1. Mine erased. Number 1, I really could have done the same thing using my calculator. What would have I punched into my calculator to do number 1? The log of 16
Square.
divided by the log of 2. And if you do that on your calculator, you get 4. That's the same answer we got when we did it the other way, right? How about let's try the next one. If we do number 2, what would we punch into our calculator? The log of 136. I would put parentheses. I think the Texas Instrument puts them there anyway, but 1 fraction 36 or 1 divided by 36 in parentheses divided by the log of 6, right? And your calculator tells you -2. That's what we got, right?
Yep.
So, we could use our calculator to do these ones, but they wanted you to practice rearranging it into exponential form. On these ones down here, we can't figure them out in exponential form because we'd have to be really good to know what the 3 decimal places were. So, now if I want to do number 20, I am going to do what on my calculator?
Log of 9.
Log of 9 divided by log of 8. Which gives me
1 point, I don't know,
057. So when they say 3 decimal places, they want 3 places after the decimal. 057. So go ahead and do number 21. Be sure to put parentheses around your fractions just so your calculator knows that goes together.
-1.226.
That's what I got.
-0.815.
Oh, you did it backwards. You have to do the log of the 9, which is on the outside, divided by the log of the base. The log of 9 divided by the log of 1/6.
Okay.
And so you should get -1.226. So the log of base m of n would be the log of n divided by the log of m. The outside number goes on top. The base goes on the bottom. All right, so now we are going to use our properties of logarithms to solve an equation. First thing we want to do is expand it out. What can I do with the x plus 3? Put it in front, right? I can take my exponent and multiply it. So I'm going to have x plus 3 times the log base 3 of 11 equals 20. So now I want to solve that for x. What might I do next?
I might divide our x.
I'm going to divide the log base 3 of 11, right?
Oh,
Because I want to get the x stuff by itself. So x plus 3 is going to equal 20 divided by the log base 3 of 11. I could write it as a fraction, but I'm going to expand it out anyway, so. Now, if I want to solve that for x, I'm going to
Subtract 3.
subtract the 3. So x is going to equal 20 divided by the log base 3 of 11 minus my 3. Now I got to expand that just a little bit farther so I can use my calculator. We're using our previous rule to expand that middle part. If I have log base 3 of 11, what am I going to do with that? How do I rewrite that? The log of 11 divided by the log of 3. Right? That was just our previous rule we just did to use our calculator to solve that.
Is this where everybody fails the class then?
I think so.
No, you can follow this.
Oh,
Now if I made you memorize it, perhaps. Now we're going to just use our calculator and round our answer to 3 decimal places.
there goes nothing.
Okay. 20 divided by, I like to use parentheses because that is grouped together. The log of 3 divided by, or the log of 11 divided by the log of 3. And I can't even hit the right keys. Minus 3. Equals. Round my answer to 3 decimal places.
6.163.
6.163. Everybody getting that number? Anybody not getting that number? We don't know. All right, so we moved our exponent out in front. We divided by this to move it to the other side. We subtracted that to move it to the other side. And then we just expanded our logarithm and punched it into our calculator.
Almond and coconut?
Easy peasy.
Oh.
So number 23, doing the exact same steps we did on the previous problem. What are we going to do first?
Watch you write it down.
Perhaps.
Put our x in the front.
I'm going to put my x minus 5 in the front. That was my exponent, right? Log base 9 of 14 equals 12. So my exponent is now multiplied by my logarithm. So now if I want to get the x by itself, I'm going to divide by my logarithm.
14. There you go.
So x minus 5 is going to equal 12 divided by the log base 9 of 14. And then to get the x by itself, I'm going to
Add that 5.
add that 5, exactly. So x is going to equal 12 divided by the log base 9 of 14 plus my 5. And then so I can use my calculator, I need to expand out my logarithm. So x is going to equal 12 divided by what?
Parentheses, log 14 divided by log 9.
Exactly. So 12 divided by, in parentheses, I'm going to do the log 14 divided by the log of 9 plus 5. And then I'm going to punch it in and compute it to 3 decimal places.
What is this? What is it? Where do you use this?
Where are you going to ever use it? Nowhere. If you went into engineering, they'd probably make you do all this just for fun. It's not fun?
It's alright.
We got 14.991.
Good, that's what I got. 14.991. I got to round that off too. Everybody getting that? So go ahead and try number 24. I'll leave that one there in case you need some reference. This is your critical thinking and problem solving skills. I didn't change my math rules. I just applied it to something else. Where in real life, are you really going to do this? You're not.
Gotcha.
You have busy. Susan on the fraction.
I would.
All right.
I haven't punched it in yet, but I'll do that. All right.
Oh.
No, it's not what we got.
Oh. Okay.
Punch it in again. Oh, I think you did that backwards again. You're going to do the log of 8 divided by the log of 1/9.
Well, you timed it at the end? In the
No.
parentheses?
No, you divide.
Oh. Figured something
Didn't change that rule.
was up.
So when I have my logarithm, log base 9 of 14, we took the log of 14 divided by the log of 9. Yeah, looks like we got it.
-4 on that? Ah. 20 divided by log of 8. Got parentheses there. Log of 9 -4. Okay.
Which get?
-25.132.
Or 133 when you round it off.
Yeah.
Okay. So, first thing you did, anytime you work with a logarithm and the variables in the exponent, you're going to put that exponent out in front so that your variable is no longer in the exponent. So, x plus 4 equals times log of 1/9, log base 1/9 of 8 equals 20. Then to get this by itself, since this was multiplied by that, we're going to divide by that. X plus 4 equals 20 divided by the log base 1/9 of 8. Then we have minus a 4 to move that over. X equals 20 divided by the log base 1/9 of 8 minus 4. So then we did 20 divided by the log of 8 divided by the log of 1/9 minus 4. And we ended up with negative 25.133. Almost could read my writing. All right.
Ooh-wee.